Hello everyone, welcome back again. Today we are going to see how to do I/O programming in Atmega 32 or Atmega 16. Both this AVR microcontroller has same pin configuration. As you can see here, this Atmega 32 has four ports. You can see here, port A is over here. You can see port B is over here. Port C is over here and port D is over here. Here is the PD7 of the port D. So other pins are there, VCC, ground. This is for the crystal oscillator, pin number 12 and pin number 13. And these three pins 30, 31, 32. This is A VCC, A ground and A reference. This is for the ADC and DACs. So you can see this port is also having some alternate function. You can see for port B, these are the alternate functions like that is used for timers, that is used for slave select, master in serial, slave input, master output, slave input, master input, slave output, and so on. Again, here at port A, we'll have ADC0, ADC1. These are the ADC channels. So in this way, this microcontroller has port pins and they have alternate functions as well. So how to do a port programming and how to select the port function. So for that, today we are going to see only how to do a port programming, that is writing to port A, B, C and D. So look at here, there are several functions, or we can say several uh, families are available of the AVR. You can see here. So we have 8 pin that is used mostly in Arduino microcontroller. We have 28 pin, 40 pin, 64 pin, 100 pin. You can see here for 8 pin, that is 80 Atmel Tiny 25, 45, 85. This is available in here only in this book. So we have only port B having 6 bits. So while for 28 pin like Atmega 8, 48, 88, they have port B, port C of 7 bits and port D that is of again 8 bits, because this is a 8-bit microcontroller. So X indicate this is port having 8 bits. So for 40 pin you will have Atmega 16 or 32, where you will get port A, B, C, D as we are seeing in our example. So this is all 8 bits port A, B, C, D. For Atmega 64 128 of 64 pin, they have port A, port B, port C, port D, port E, port F and port G having 5 bits. While for 100 pin microcontroller, so many pins, so many ports. You can see from port A to port L, where the port G is of 6 bits only. So these are the some AVR family members having this particular bit. So which microcontroller you have to choose? So you have to select accordingly how many port pins you wanted or how many alternate functions that you wanted. Now how to select this alternate function? So basically we are going to see how to select port as output port. So for that we need to understand for Atmega 32 or Atmega 16 we have 4 ports. So in that, port A is there, port B is there, port C is there and port D is there. So how to select that port A to be as output, how to select port B to be as output, as well as port C as output and port D as output, that's solely depending upon this resistor called DDRA. DDRA, DDRB, DDRC and DDRD. So this is a direction resistor. So kept in mind, you have to select the direction of the port using this DD resistor. So DDR means we can say directly data direction. So data direction A, data direction B, data direction C, data direction D. So each port has its own data direction resistor. So we can say for port A DDRA, for port B DDRB, for port C DDRC and for port D DDRD. How to decide that port A is to be as output, port B to be as output, port C to be as output and port D to be as output. So that is depending upon this DDRA resistor. DDRA resistor, where we can say this DDRA resistor will decide the direction of all these ports. If we write FF to it, so if we suppose to write FF to it, so it means that this port is considered to be as output port. Okay, so let me write here. If we write 0xFF to this port direction data direction register, so then the port A is called to be as output. If we write 0x00, that is considered to be as input port. So kept in mind, DDRA-FF, the port A will be in action, and DDRA-00, the pin A will be in action. So pin A is input port. So whatsoever written outside the pin A, it will be read by this pin A register, and port A, so it will send data to output port. Okay, we can say send data to output world. So if you have to interface an LED, so data should be given port A as an output port. It should be decided to be as output port. Data should be given by port A. And if we interfacing sensors to like port A, so pin A should be act as an input port. So it will read the data from pin A. Okay, so for this we are going to see actual how to do a practical way to program input output of AVR microcontroller. We'll directly go to the notepad. So before going to the notepad, let me remind you that this is the software where we can do programming of AVR microcontroller. So for that purpose we need to go into file. We have to create a project. So I am going to create an empty project. We give name to it. So suppose we'll do IO programming. So I am using name IO programming, and we need to decide a location for it. Location is very important because we need to create some sort of other files, so that's why the location is very important. So we have to create a folder for that purpose. Let me go to suppose port D. I'll create new folder here, say AVR programming. Create new folder within AVR programming as IO programming. Now I'm done. So I'll say okay now. So if we go into the folder, we'll see there the project is created, IO program. See here the project file. Okay. The next part is we have to take a new file and we have to save it by using Control S. You can save it. Where you have to save it? You have to save it to the location where the project has been created. So take it at middle, go into IO programming, and we have to give name main.c. Kept in mind, this is very important because while making make file, this name is very important. So by default the make file name has a main. We'll take the file name to be as main.c. I'll save it. So this is another text file, not like this to it, but main.c. So here I have to add, the next step is to add that main.c file to your project. So I'll adding it. And the next part is we have to create m file. Without m file we cannot create, cannot actually compile the code, or we can say in here make all the code. The name is here make all, so it make an hex file. So here the first thing, you have to go into make file and we have to make it, file name to be as main. Okay, I'm going to take MCU type. I'll take Atmega 16 or Atmega 32. We can take Atmega 16 now here. Make file, then output format to be. I'm going to save it, save as. Where we have to save it? We have to save it where we have created our project. So go into AVR program. I'm going to not make any change in this name because this is the name that is required. Make file. I'm not going to change anything. I'll save it. Close this file, and we have to add that make file over. Add files. Add make. So make file is added. You can see here make file contains all the registers, all the register that is required. Here all the things that are available in here in that. Okay, I'll close it. Now we have to write a program. How to write a program? So writing a programming is very simple. You have to include first of all the header file, and see include uh, header file here is avr/io.h. Okay, then I am going to take int main bracket open bracket close, then main function bracket open bracket close, If I taking here int, I'm going to write return the case sensitive, return 0 for int. So now what we need, if we have to program, IO port, so we need to understand that there is a register called DDRA. So DDRA, suppose we have to write it to be as 0x, kept in mind 0, not okay, semicolon, that is a statement terminator as like C. Here I am writing that port A acts as output, as I am writing DDRA. Okay, we are going to write directly port A is equal to 0xFF, writing FF, which means that this particular port A is having a data called FF. So if I run this program, so how to run this program, we have to first of all go into tools, make clean. Okay, so we'll go into folder, what is done, main, make file, IO programming. Then I am going to go into notepad, make. You will see here, after making all, you will get the message process exit code 0. You will see in that folder there are several files come where main.hex file is important. So where to run this program, so we require a Proteus software. So I have already on my so Proteus, I'm going to run this Proteus software, where we are going to take a simple Atmega 16 or Atmega 32 microcontroller. We are going to give the file of give the path of the file in.hex file, and then open here. I'll go into file and create a new project in the Proteus file, so that will be saved for the other purposes. Using Proteus is very simple to run your microcontroller based code to it. I'll create new project, but I need a path. So I'm going to give a path where I have stored my program. Select this folder. Next, do not create a PC. No, but for just a simulation, it will create a path like this. So where I need to do only one thing, library pick part, where I am going to see Atmega. There is that Atmega. I'm going to see Atmega 16. I'll select it, place over here. You can see here Atmega 16 is placed as like as pins as like Atmega 32. So what is the next step? I'm going to just browse. I'm going to give the header file from that folder. Say OK. I'll run. You can see here the port A, that is the required. So you can see here the port A, they are all clone to RAID, and the rest are they having no any functions. We have not defined at all. That's why they having the value that is don't know, that is not do not RAID. We can see that we have programmed this particular port. So if we have to modify the code as like this, if we go into programmers notepad and we'll take another register DDRA, DRB suppose be as 0xF, kept in mind 0. Okay, I'll take DDRC 0xFF and DDR 0xFF. Then we'll copy paste all these things, make the changes as port B, port C, port D. Okay, so we'll see that if we run this particular code, all things, means all port should get the value called 111. I'll just call it to create its hex file. If it is done, I'll go to Proteus. I'll stop the previous running and next run. We'll see that all the ports now they are cloned, like port C, port D, can see port B here and port A. So all ports are blown now because of the program that we have written. So now if you have to do blinking of this port, so basically how to do blinking of this port, we need to take a while loop in here. It will continuously move, means indefinitely move for very long timing, and we are going to take the value of all these ports to be as 00. But if we write like this, port A, all they are like high, and then again port 0, then all will be low. It will not run like this. So for that purpose, we need to understand that we need to do some add some delay into that. So for that, I'll have a header file called util/delay.h. util/delay.h. I'll going to introduce here underscore delay underscore. This is inbuilt function. I'll take 100 millisecond time according to this particular header file. I'll again clean it to remove all the files. Then going to make all the files. Okay. Then now I'll stop it. I'll run it. You can see here this port is blinking now. You can see here the port is blinking. Port C is blinking, D is blinking, B is blinking, and E is also blinking. So this is the way you can program the port of AVR 16 or AVR 32 microcontroller, and then you will see that to do program in AVR and add the hex files in this particular thing, you will get the port blink. As you can see here, I have connected the LEDs over here for port B. I'm going to insert the hex file that we have created to blink the port. We are programming hex. Say OK. So you will see here LEDs are there, they are blinking. Like for 1, the LEDs are all glown, and for 0, the LEDs are off. So in this way, you can do a port programming, LED array port programming, or LED blinking using AVR microcontroller, and for simulation, you can use OTS. Thank you for watching my